Okay, what is the essence of design? We are dealing with some design computing. Okay, we are not going to learn how to develop your design or how to expand your design ideas. We are not going to deal with some design studio related issues. We are going to deal with some design computing issues, okay, technical aspects of design. Even if technical aspect of design tools, whatever, we need to figure out some type of quantitative approaches regarding design and design computing. So actually I showed you this one before, the definition of design. Actually, it's not easy to define design. There is no such effort or no 100% sure definition about design, okay? Of course, there are amount of design definition or design description. Big guys, big designers, they tend to say something about design, okay? But it's their perspective, not yours, okay? So that's why I want to show you this one of the definition. This one of the definitions from researchers in design computing domain. They define design using those terms. Structured arrangement of design units. Very simple, okay? Structured arrangement of design units or design elements. What is design units? What are design elements? First one, physical element that forms a design. Second one, an element of design that a designer can cognitively deal with. So what is the number one? What is this? Something visible, okay? For architect, interior designers, number one could be floors, doors, walls, wall surfaces, building facade, windows, furniture, and lots of design related elements. What is the second one? What this means? Some cognitively deal with things, something invisible. What is invisible in your design? That is design concept, okay? Design concept usually something behind your design, okay? Your visualization is very explicit, but this one is something implicit behind your something, okay? Sometimes you can deliver directly your design concept to your design physical elements, but anyway, something behind something cognitive things, they are anyway one part of design units, okay? That's my point. So what to visualize? Both of them, okay? Not only focusing on the first one, physical things, I like to let you know, and I like to put more emphasis on some second one, design concept, so-called diagrams, something concrete, something abstraction, okay? And so on. What is designing? Design elements making plus something process, okay? Some time axis. An act of creating and elaborating a design. So designing is equivalent to modeling a design model, okay? You have your design idea, very creative and unique idea. Let's assume that you have idea, okay? Design process simply means making your model. Your model, clay model, foam board model, no, computational model, okay? In this class, usually, okay? Sometimes you use SketchUp. In that case, this one going to be SketchUp model. In this class, 3D Max model, 3D Max file, okay? Next semester, if you learn Revit, that's going to be Revit model, okay? If you want to use ArchiCAD file, or Rhino file, Grasshopper model, whatever it is, that's going to be your computational model and digital design representation, presentation things, plan, 3D, sketch, animation, anything for design representation can be extracted from your computational model. Okay, what if we don't have this model? From your idea to your sketch, from your idea to your 3D model, floor plan, amount of arrows directly from your idea to final outputs, it's really time consuming, repetitive, and tedious, okay? You have to work 24/7 only for your design development. But thanks to this computational model, you can extract anything you want based upon very well-defined and well-structured model, okay? So if you choose this model, very low-quality application or very easy to use tool, SketchUp, or if you use ArchiCAD or Revit, which one's better? Because of different capability and capacity, of course, the better one, the better, okay, for your final. I mean, your design, the presentation, and visualization. One source, multi-use, okay? Computational model to your presentation method. But from your idea to your computational model, if you change your mind, if you update your idea, you don't need to update plan 3D pictures, sketch animation, whatever, okay? Only one thing, okay? Your computational model should be updated, okay? This process. And then your material for design the presentation going to be extracted, okay? Here is the very important reason why you need to use powerful and something realistic computer software or some model generator, okay? If you have more information, the term more here means amount of related information regarding this building, so-called building information. That is why building information modeling is the way to go. This is the next semester's topic, a little bit in this class, okay? So designing is equivalent to modeling a design model. What's next? Design idea from your head. No one can see your idea. No one can open your brain, okay? No one knows your design before you made something, okay? Create model and extract visualizations, design visualizations. So what's next? Actually, design aims to be realized in real world, okay? In real world. But in school, in your design studio, it's very expensive. But that's not the only one reason, okay? Very expensive, time consuming, and there are amount of more people we need, okay? Anyway, design visualization is usually the final stage in design studio. Of course, design critic or some design competition, evaluation, lots of things we have, but anyway, they are totally based upon your visualization stuff. So design is going to be realized if it is well visualized, attractive, convincing, feasible. If your design is not attractive, your owners, public, other people not going to pay the money for realizing this building, okay? It should be attractive, should be convincing. What is the term convince means? What is the term convince means? Convince. What's convincing? The meaning of convincing. No one knows? Trust? Okay, good. Able to understand. I'm not sure it's 100% same to convincing, but anyway, able to understand what? Able to understand that is good design? So the process of design is process of this one, okay? You should be able to convince, understand that other people believes that your design is good design, okay? What if you failed to convince your instructor in your design critique? If you fail to make it convincing, how to make others, other people, general people, public people, someone who gonna use that building design in the future, okay? So design process simply means some type of convincing process to others. If you convinced 100%, you only, that is not a design. There is a good term for that one. That one is art, okay? That is art. But this is design. Supposed to be convinced by others, not you, okay? Okay, that's the difference between art and design. Anyway, your visualization, it's really, really important. And then on-site construction, pre-prep, shop prototyping, and so on, they're going to be used for this one. But we are focusing on this area only in this class. We are dealing with geometric modeling and visualization in this course. Digital design and visualization. So-called geometry-oriented approach to the design. So what is geometry-oriented approach? What else? What else? What is not geometry-oriented approach? Let's quickly take a look at the history of design, history of architecture. Architectural design versus construction. As you know, this is Da Vinci drawing, okay? Vitruvian Man as reflecting Vitruvius, okay? Marcus Vitruvius Polio is the man around 2,000 years ago, okay? He believed as the first architectural designer. He invented floor plan, elevation, section, something like standardized drawings in architecture domain, okay? So-called plans, elevation, perspectives to convey design intent. Very typical type of drawings invented by Vitruvius, okay, 2,000 years ago. 400 years ago, 500 years ago, 600 years ago, in Renaissance area, Leon Battista Alberti proposed separation between design and construction. What this means by, before Alberti, design and construction, they are integrated, okay? In other words, I told you in your design studio, your final goal is design representation, design presentation, design visualization. You are not in charge of making them realized, okay? How that possible? Because Alberti suggested we have to differentiate the intellectual task of design from the craft of construction, okay? When? 600 years ago. Compared to long history of human beings, 600 years, it's really short, okay? Not that long. You have to be aware of this historic thing. Modern architecture, so-called modernism, from this phrase, form follows function, coined by an architect, Louis Sullivan, 100 years ago. 50 years ago, the first CAD tool has been invented, okay? So-called 2D CAD system. But nowadays, building information modeling, the most advanced CAD systems, what we are dealing with at least 2D CAD or 3D visualization in BIM domain. Anyway, it's not a long history thing compared to human history, several hundred thousands of years, but computer-aided design, so-called CAD or 3D computer graphics, digital design, its history just begun, okay? 40, 50 years. How about you guys? 2 years, 3 years, 4 years, okay? So, this is a brief history of the architecture, design, construction, something. Let's talk about the history of CAD, history of computer-aided design. Take a look. This is the original, conventional approach, history of computer-aided design. Take a look. Our current interest is here, actually, geometry-oriented approach to design. Take a look. There is a box. What to know for making this box? We have to define vertices, their connections, okay? As a result, edges, okay, lines. At least 3 edges going to create one face, faces, polygons, surfaces, okay? So, what if you wanna transform the shape of this box? You have to control one of them, okay? Vertex, edge, face, polygon, and then you can change the shape, okay? That's the fundamental mechanism of geometric modification in 3D Max. 3D Max, Rhino, SketchUp. But in SketchUp, there is no way to control vertices, only edges and faces. But in 3D Max, you may find out the name listed here in your modification tab, in edit poly mode, and so on. You're gonna learn how to elaborate, how to control them. Conventional CAD system only deals with geometry, because people believe that geometric shape is all about design at that time. But nowadays, I told you, there are a lot more things. Geometry is very important, okay? It's important, critical. But it is just a subset of design, not everything, okay? So what's next? Let's take a look at this one. What else except geometry-oriented approach? This is building object-oriented approach. Take a look. Our next topic, BIM, is here, simply described. Here is a site. Take a look at this notation. One site has one ... star, means this notation means one or many, okay? So one site has one or many buildings. One building has one or many floors. One floor has one or many spaces, rooms, okay? How about this? One or many spaces going to be grouped by 0 or many space group. How about this floor space? How about circulation space? How about building common area? How about interior architecture, design spaces? How about nutrition department spaces? They can be grouped, okay? How about interior facilities? Computers, desks, chairs, they all one part of the space, room, okay? But actually, take a look. Yellow part is our main subject, our main object. But actually, in real world, there are lots of structure, okay? Slab, ceiling, roof, beam, column, foundation, all they are something visible objects, so-called structure. How about opening? Opening could be one part of wall. When you have opening, you can place windows or doors, okay? So this is the structure we have. The white colored part is something visible, structured elements, okay? Actually, yellow parts, they are sometimes not visible or sometimes not explicitly well defined. They are something conceptual objects. Okay, sometimes they are some group of objects. That's my point. How about this approach? Which one is looking advanced, looking realistic? Okay, can we create automobile, cell phone, smartphones based upon this approach? There is no such things, okay? Simply because this is building information modeling approach. But actually, take a look this one again. This is not just for building. What if you want to create very well-designed your own automobile, your own smartphone products, your design things, your clothes, your monster, for your game, whatever it is. You can design anything because it's geometry-oriented approach, okay? General purpose. Something has geometry. This is fitting every object in the world. But this approach only available for buildings, okay? For the building. That's the difference between those two approaches. But another important thing you have to know is they are not separated. They are not something separated. Let's take a look at this one. This is conventional geometry-oriented approach. Think about the floor plan. You draw something like this and you say this is your design, okay, floor plan. There is a rectangle shape and you put office label. And people can be aware of, okay, there is an office. How about computers? Computer doesn't know what is that, okay? Computer doesn't know what is this office. Just it represents office label on top of this rectangle shape. That is polygon, okay, polyline. That is why we say dummy geometry, okay? It's not smart, not intelligent, just geometry. But take a look at this approach. Space object in BIM model. It has amount of space and building related information. How about entire information we had before when CAD system? They are just one line of this information. 3D geometry data, geometric information. This is still very important in this approach. But my point here is, it is just one part of it, okay, not 100%. But before this approach, when we are using just CAD system, it's everything about your design. But nowadays, we have a lot more additional information. So my point here is they are not totally separated, okay? This one is totally a subset of this information modeling approach. That's my point, okay? Okay. I showed you this one before. We are aiming to design using design computing technologies, okay? But visualization is the subject for this semester. Focusing on visualization before handling BIM, okay? That's the topic. But anyway, I told you we're gonna deal with Revit and some more BIM applications as an introductory course.